All right, hi everyone. I'm Alice from House of ZK. Very excited to be moderating this discussion between Anthony from ZKsync and Vanishree from Fermah about their new integration together. So as some context, Fermah has recently integrated with ZKsync's ZK Stack and will be generating proofs for the Elastic Network. So we'll be going into some more details about what this integration means, and then also how any developers in the audience can get involved from this as well. So to start, I'm wondering if we can first start off with an introduction about yourselves, and then also the backgrounds of your projects. So Vanishree, wanted to hear more about kind of your origin story into the space and the kind of unique value proposition behind Fermah, how it may compare to other proving services in the market. And then Anthony, on your side, wanted to also hear more about yourself, and then also how Elastic Network addresses any limitations present with other multi-chain solutions.
Sure. So my name is Vanishree Rao. I'm the founder of Fermah. We are building a universal proof market, and by way of introduction, my background is in cryptography, and over time I saw this gap in the industry for infrastructure for proof generation, which is hard to do. And this is when we thought that it is important to have delegate and focus on other things, kind of a situation for the world to embrace ZK a little bit more easily. Yeah, over to you, Anthony.
Sure. Yeah, Anthony Rose. I lead the technical team at Matter Labs. And Matter Labs is a team that's kind of been the originator of the ZKsync protocol. So ZKsync has been around for a little while now and has had a few iterations. So started over 4 or 5 years ago and built initially a app-specific ZK rollup. So the first version, which is now known as ZKsync Lite, was demonstrating that you can do ZK L2s, but in a way that was sort of specific to DeFi primitives. So you could use ZKsync for payments, swaps, mint an NFT, but really as a kind of proof of concept for what we've spent maybe the last 3 years building, which is general purpose compute with ZK. These days, our focus is on what we call the Elastic Network. So ZK gives you the ability to kind of build this horizontally scalable architecture where you don't introduce trust assumptions or introduce other compromises that you might see with different architectures in the past, where they're talking about really how we get to like global scale with blockchains. So yeah, we're excited to talk more about our integrations with Fermah as we really think about how we bring high scale to the proving side.
Yeah, great. And I'm wondering, Anthony, if you can speak more about why the team decided to outsource proof generation to Fermah specifically. And Vanishree, on your side, I'm wondering if you can speak about how Fermah addresses any kinds of current bottlenecks or enhances proof generation within Elastic Network.
Yeah, I can start. So over the last few years, so when we started building this ecosystem, the first L2 that we deployed into it was ZKsync Era. So we had one rollup, centralized proving, much like many of the L2s that exist today. But the architecture that we're building is such that teams can deploy into this network. So we've already seen many of these start to go online over the last few months, where you have this shared bridge on L1 for the kind of shared value for the network, and then teams deploying their L2, the ZK chain, into that space. That gives them a bunch of benefits with respect to interop, with respect to proof aggregation, and really talk about some of the user experience features that come with it. But when we're thinking about where the system is going, right, the idea is that you can start to build an architecture that can scale to applications that can support billions of people. And this is meant to be an open protocol, a network that is kind of much bigger than any one company. So Matter Labs, the sort of originator of it, didn't want to be the team kind of building everything. So we have now the order of like 10 chains online. ZKsync is still doing a large fraction of Matter Labs is still doing a large fraction of the proving. But when you kind of extrapolate to where we're going, we are going to need to see proving at real scale. So ultimately, in evaluating the prover networks, we wanted to partner with some of the strongest teams in the space. And of course, Fermah is right up there.
Yeah, we are ultra excited about this partnership. And to your question on what this partnership means for the ZK chains, from our side, we yeah, like I said, we are super excited about this integration and about this chat where we dive deep on this integration, and we are coming to it from the point of view of understanding what the pain points are for people building in the Elastic network. And to Anthony's point, ZKsync Matter Labs, everything that is built by Matter Labs, it's one of the industry leading set of projects, right? The Elastic chain is industry leading also in the amount of proofs that they generate on a per unit time. And this is to his point, when as they're going to get billions of people, billions of transactions, that level of activity, you need scalability, you need modularity, so that Matter Labs can focus on their business goals while delegating on this part of their stack to us, where this is our goal.
Yeah, that's incredible, and it's very fascinating to think that right now we've improved so much within proof generation, and now we have these proving marketplaces and services like Fermah that are available, where the burden of proof generation doesn't just have to be on the end user, and now we can have those proofs delegated, and those end developers and users can now focus on the kind of the business logic behind their applications rather than just the burdens of proving. So very incredible strides that we're making here. I wanted to also ask you both about decentralized proving, because on Fermah's side, I know that Fermah is operating on a decentralized proof marketplace model. And then on ZKsync side, one of the core visions is with decentralization as well. So I'm wondering if you can both speak about some of the advantages that come with decentralized proving.
I can, give you some sense of how we're thinking about it. So, building systems like this is obviously very complex. I think pretty much every single team to first approximation has taken the approach of build the centralized version of the system first, and as a function of you kind of making progress, solving problems, reaching scale, finding, like getting to the point where you feel like secure in the system as it is. We need to make progress on where we really want to be, right? None of these systems are designed, or at least, when we think about the design for the Elastic Network, the goal is to build a resilient, decentralized protocol that can kind of be owned by the community. So as much as Matter Labs was the originator of the network, the goal is obviously not to stay that way, right? And we've gone through a bunch of different work to decentralize various parts of the system. So, going through the work of decentralizing the ownership of the protocol happened last year, launch of the token foundation and sort of governance model. So nobody can now update the ZKsync protocol without going through on-chain governance. On the sequencer side, obviously another massively important area to decentralize. We've kind of, again, taken many milestones, and today we have a decentralized sequencer for ZKsync Era, and as part of the functionality available to chains building with the ZK stack, not all the way to being like completely decentralized at this point, but kind of like iterative steps to where we want to be. And then obviously on the provers as well. So we want to get to a point where, network resiliency requires decentralization. It requires us to be resilient against failures of specific operators, failures of specific entities in the space. Matter Lab should be able to disappear, and ZKsync can continue on. So for us, it's everything needs to be decentralized, but we don't want to do all of the work. So we can partner with teams and build the network in a way that's very collaborative and much bigger than one team.
I think Anthony made a very good point on the need for decentralization. It is not decentralization for the sake of decentralization, right? Not just to, of course, it is noble and good to aim to stick to some ideological reasons ideological reasons that'll motivate us to have decentralization in every every element of the stack, but like Anthony said, there are specific reasons that our lack of decentralization can be negatively felt. Specifically for the proving layer, why decentralization? It is because it can bring the cost down. It can make proving fast. It can ensure competition. It can keep low price in the long run. And it helps us align with the core ethos, which drives the entire crypto, and also very specifically the core ethos of ZKsync.
And I really like how you both mentioned that, like implementing decentralization is not just for the sake of decentralization, but there's many other benefits that come along with reducing proving times, the costs, and just addressing that kind of core ethos behind what brings all of us to this space. So it's really great to hear. And then I'm also wondering if you both can speak about how the end developers' experience will be affected. So on Fermah's side, how does Fermah kind of abstract away the heavy lifting of ZK proving for any kinds of teams that are building on Elastic Network? And for your side, Anthony, how do you see the user experience evolving in Elastic Network with the outsourcing of these proofs to Fermah?
Yeah, I can jump in. For us, I think much of it should be abstracted away from the end user. If we're talking about, people interacting with the DEX, playing a game, whatever it happens to be, whatever application they're using on chain. The proving happens asynchronously from the user activity, right? So I want to do my token swap. I do that on my favorite DEX. The block gets sealed on the ZK chain, and then the proof is generated. So the proof gives you the correctness guarantees that the system is operating as you expect, and but really, it should only be there to kind of provide that, peace of mind, that comfort, and also, mitigation against anything being malicious or bugs in the system. So users should really not see this for most of the operations you're doing day to day. That being said, with this architecture, where you have, a bunch of ZK chains kind of deployed into this ecosystem, ZK can give you interoperability. So, for example, if I want to send 10 USDC to my friend, I might have my wallet on chain A, they might have their wallet on chain B, and without having to go through like a bridge, which introduces, security risks, or like some entity in the middle who's going to take some fraction of our value, ZK lets you do this natively at the protocol layer. So one of the really nice things about starting to integrate with, teams specializing on building high performance, ZK systems, and I mean, obviously this is kind of what we've been building ourselves, but to keep partnering in this space is, it matters to keep making the systems more efficient, right? We want the proving to be fast, we want the proving to be cheap, and this is where users will have some sensitivity to it, because thinking through even that example of sending 10 USDC, the proof needs to be generated for the transaction send event, for the receive event to happen, right? Because the systems need to know that this event on chain A can kind of trigger some event on chain B. So, partnering with teams and making that generation speed for the ZK proof very, very fast is going to mean that you kind of make the user experience increasingly better, and obviously, driving the cost down.
And I think Anthony captured it completely. I would only rephrase it. I think he captured it completely. So I think the effect of integration is felt by users in two ends, right? One is the end user will experience when we lower the cost. That's one thing that they'll experience. When we increase the speed, that's another thing that they'll. So you'll see faster settlements, things like that. Another part where you will. So this is the ongoing experience where people will see the effect. Another area where people will see the effect is the integration. So when other ZK chains, imagine other ZK chains that are building in the Elastic Network now, they don't have to think about what is their proving infrastructure. With so much work that is already done by integrating with the ZK stack, they can just start without worrying about this stack at all. Two areas where you can see the effect of this integration.
Yeah, this is a really, really important point. So for standing up a ZK rollup a year ago was a lot of work and a non-trivial amount of resources. But providing these integrations means that you can, basically take the ZK stack and just deploy a chain in minutes and wire into infrastructure to mean that you don't have to go provision a bunch of GPUs and pay Google a load of money. Really lowering the barrier to entry for people building infrastructure and building ZK chains.
Yeah, absolutely. And now they don't have to worry about kind of the exact proving infrastructure that goes along, and they can just focus on other parts of their application and leave all the heavy lifting to just the back end. Yeah, got it. And I'm also curious to hear some of the use cases and applications that you see benefiting from this integration. Any that you see have a lot of potential in, ones that you're personally excited about, or maybe ones that you hope will be developed in the future?
From my side, I don't think there's like one specific thing, right? So when we think about the ZK stack, it's a toolkit for people to be able to customize infrastructure in a way that makes sense for whatever they want to do. So, you can deploy a ZK chain which has, custom gas token, or pick your gas token, pick your DA layer. You can integrate with Celestia, Eigen, Avail. Pick your configuration for your sequencer, like my validator set or on a centralized sequencer. And of course, pick whichever proving network you want to run with, or run centralized provers you want to do. So at least for us, our goal is to make the ZK stack just an incredible toolkit for custom chains that can then be deployed into this network that gives you, full interop from day one, from moment one with anyone in the network. So you can deploy a chain today, and through this ZK-based interop, immediately you've got access to all of the users deployed on Abstract or Lens, deploying very soon, or Era, or whatever it happens to be. For me, it's not one use case necessarily, but just kind of really giving developers a toolkit for building exactly what they need at the infrastructure layer.
I think so. If Fermah were to add value in only one of the two important metrics, right, proving time or proving cost, then you're kind of limiting the applications. For example, imagine if we are only adding value in cost and not in proving time, then you can then say, oh, we can now hopefully see a lot more. Already there is a ton of activity on Elastic Chains, and it's phenomenally successful, and so many more projects are building on the ZK stack. And if we are to think about what are the kinds of projects that'll build more easily because of this, there's no limitation, because we are adding value in pretty much every important metric. Like Anthony said, anyone who wants to build an application that can make use of ZK one way or the other, ZK stack is building in every component of the stack to make it easy for them, including proof market area.
Mm-hmm. Yeah, and it's really great to hear that it's not just one use case being affected, but as you say, Anthony and Vanishree, providing a toolkit for a variety of these different use cases to be enabled. So very exciting to hear all of that. And just as a last question before we end today's discussion, I'm wondering if you both can speak about some of the major milestones that are coming up with this new integration, and how any developers in the audience can get involved.
Yeah, I'll offer a few, and then you can add all the ones I miss. At least for us, we have a bunch of milestones that are directly related to the relationship, and a bunch of milestones that are sort of adjacent to it. So we have the most exciting thing I would say on us when it comes to the proof system is we're preparing the next generation of our proof system. So kind of today, the way that the system works is the Boojum proof system, as we call it, is very coupled to the choice of virtual machine. So you have the Era virtual machine, and then you prove the Era virtual machine. So we're making a major upgrade to our proof system that will again give users more customization, because you can essentially we'll prove the RISC-V instruction set, so you can customize your virtual machine as well as the other things that the ZK stack offers. So when I think about the kind of milestones that we're expecting over the next few months, we'll see obviously integrations with the current version of the proof system that start to become increasingly decentralized. Then we'll see a major upgrade to the proof system, and then obviously we start to see that one become decentralized. So this year our proof system will be going through huge expansion in terms of its capabilities and scale. So with centralized proof systems, you're kind of bound to the number of GPUs that you've got that you're operating, and we don't want to continue to invest in centralized proof systems. So the milestones for us are going to be really exciting when we start to see proofs for the mainnet being outsourced. So testnet's coming, mainnet's coming.
We are very excited about integrating with Boojum 2.0 also. We have so milestones, internal milestones wise. We are integrating Boojum, and even double clicking the integration will look like so. There is the API, how Fermah talks to ZKsync, and then there is how the proofs are getting generated. So if you look at Boojum, it's this variable dependency structure leading up to lots of recursion, leading up to the final proof. So what Fermah will do is it'll take a batch and it'll orchestrate the entire proof generation, the entire steps of proof generation, the entire workflow of proof generation. So there is integration on that part, and like I said, there is integration on how we talk to ZKsync and get the proof requests and generate proofs and send it back. So there is that integration, and then most of what we have done will port over to the situation when Boojum 2.0 will go live. And this is about the integration, and this is some other milestones are very soon. I might be front running our announcements, but very soon we'll have testnets coming up, multi-phase testnet coming up. Very exciting.
Yeah, amazing. Yeah, very exciting time indeed. Lots of new developments, testnet coming up. So really appreciate you both for coming in today and to talk about the integration. And yeah, thank you so much.
Thank you so much, Alice. Thank you, Anthony.